All right, so here we're supposed to convert this given I system to an E system using slack variables. Then we're supposed to construct a table of all basic solutions of the E system. For each basic solution, then we'll indicate whether or not it is feasible. All right, so again, this is our I system. And so we're supposed to convert that to the E system. So basically converting it from the inequalities to the equalities. Well, what we do is we just add a slack variable. So that'd be 3x1 plus 8x2 plus. Now we just have s1, and that's going to equal 24. And now we just say x1 and x2 are both still greater than or equal to 0. So that's going to be our E system. Now, what we have to do is we have to say, okay, well, now we have x1, we have x2, and we have s1, and then we have to decide, is it feasible or not? Okay. All right. So we set up our system. So we have a 0 and a 0, and we have a 0 and we have a 0, and then we also have a 0 and a 0. So we set all those up, and then we kind of simplify from there. So if we plug in zeros here, 0, 0, that means S1 is 24. Now, since those are all positive, yes, that's going to be a feasible solution. Okay. Now, if we plug in x1 is 0 and s1 is 0, that means this one has to be a 3. Now, is that feasible? Yeah, that's feasible. Oops, not well, true. Feasible, yes. We probably should put a y for yes instead of a t for true. So, yes, maybe we'll just write yes, and that'll be easier. And then the next one we plug in x2 and s1 is 0. So if that's 0 and that's 0, then x1 has to be 8. So now we have 8, 0, 0. Those are all positive. So yes, that's a feasible solution. And that's all they really want here. They just want to know, set up the table and then see if it's a feasible solution or not. So how about we do the next one? Same rules. And so first we have to convert the I system here to an E system. So what we're going to add S1 here. So that's going to be x1 plus 3x2 plus s1 equals 18. And then we have a 5x1 plus a 4x2. And now we have plus an s2 equals 35. And our x1 and x2 are both going to still be greater than equal to 0. Okay. Now, sometimes I put a space here and put S1 and then there's nothing down here and then it's blank here and S2 here so they kind of lines up so we know what we're doing. But you don't have to always do that, and so it just kind of depends on your own personal way you want to do this. So we have X1, then we have X2, we have S1, we have S2. Now let's just kind of put all our zeros in here. So we'll have a 0 and a 0, we'll have a 0 and a 0, we'll have a 0 and a 0. That's all of them with first x1. Now we'll go down here. Okay, now we have a 0 and a 0 and a 0 and a 0. Now we have all of them for this one. And then we have only one more, 0 and 0. All right. And I guess we can go ahead and write, is it feasible over here? And that's going to be our column that tells us yes or no. All right, so we plug in x1 and x2 are 0. That says that, well, s1 is going to be 18. So that gives us s1 is 18. Now, if we plug in 0 and 0 here, s2 is 35. So is that feasible? Yes, they're all positive, so it's possible. All right, so now we plug in x1 is 0, s1 is 0. So that one is 0, that one is 0. So now we solve for x2. That looks to be a 6. Okay, so that works. Now, if we plug in x1 and this case x2 is 6, and that's going to give us, okay, well, 0, 24, subtract 24 from here, we get 1, 1. So s2 is 11. Okay, so that works. So that's feasible. Now we plug S or X1 and S2 here. That one and that one are 0. So X2, now we divide by 4. So that looks like X2 is 35 over 4. So that's not such a nice one because now we plug that back up into here. And so now we have a 0. And now we have, well, we're going to have a what? 3 times. Now we have a 35 over 4. plus our S1 equals 18. And so that's going to be 3 times that. And we're subtract that. So I'm just going to do that in my calculator here. So 18 minus the 3 times 35 divided by 4, make that a fraction, and I get a negative 33 over 4. So that's negative 33 over 4. That one has a negative, so that's not feasible. Okay. Again, I just took and plugged this in my calculator, said 18 minus this, convert it to a fraction, and that does it. So let's go ahead and show you how that works. In case you forgot how to convert to fractions. And so I just took 18 minus, and then I did the, what was it again? It was the 3 times 35 divided by 4, make it a fraction, and I get a negative 33 over 4. So that's all I did there. And going back over here. All right, now we have x2 and s2 are 0. So that means here, if we solve that one, we're going to say, okay, 5x1 is 35. So that looks like that's going to be, wait. We're on S1. I'm doing the wrong one. X2 and S1, x2 and S1. So those two are 0. So that's 18. So that gives us 18. And then over here, if that's going to be, so that's going to be 5 times 18. And then that's going to be a 0. And then that's going to equal, our S2 is going to equal 35. So 35 minus 5 times 18. And that gives me a negative 55. Okay, so that's a negative, so that's not feasible. All right, so now we have x2 is 0, s2 is 0, so that's 0, that's 0. So that means x1 is going to be 35 divided by 5, which gives us a 7. Now 7 plus 0 is going to be that, so then subtract that from there. So 18 minus 7, that gives us 11. So that one back to feasible. And now if those are both 0, then we have to do a simplification. So we're going to have to say, okay, well then x1 plus 3x2 equals 18, and 5x1 plus 4x2 equals 35. All right, so now we have to get rid of some variables here. And so if we multiply this one times what? A negative 5, we get a negative 5x1, and then minus 15x2 equals, and then the 5 times the 18 is going to be a negative 90. So here we have the 15 minus the 4, so that's going to be what? A negative 11, x2 equals, and then we have the 90 minus the 35, which is going to be a minus 55, so x2 is equal to 5. So that's a 5. All right, so that says if x2 is 5, that's going to be 15, subtract that, that's going to give us 3. Okay. And again, these are all positive, so yes, that's going to be a feasible solution. Okay. All right, so let's stop there and then we'll come back for some more.